let's look at it. All right, so again, where a sequence is just an ordered list of numbers, a series, this is an expression, that indicates the sum, keyword there, the sum of a certain number of terms of a sequence. A sequence is your ordered list of terms, so 1, 3, 5, 7, etc. A series is going to be an expression that will ask you to add or find the sum of a certain part of the sequence, okay? So you might be finding the sum of the first 20 terms, the first 100 terms, whatever it is, okay? Sequence is a list of numbers. Series is the sum.
So just adding the sequence together.
Yes. Yep. For the most part, it will tell you like of the first 20 terms. So you're not necessarily adding all of them. But yeah, essentially just the sum of a sequence. Yeah. Okay. What we call summation notation, this is something completely new to you, and it will look bizarre at first until you understand what it means, but summation notation uses the Greek letter sigma, which you can see down in examples 1 and 2 right below. I'm not super awesome at drawing it, but you can just do your best. But it's a Greek letter, capital Greek letter sigma. And this is just a way to express a series in kind of like an abbreviation. Sigma notation is a way to express a series in an abbreviated way. All right, let me give you an example of something you might see. Okay, so this sigma notation is, believe it or not, this is telling you what numbers to add. Yeah.
Can you like turn the brightness up on the screen?
It's hard to see.
You can't see that very well? Okay. Let me do this. Let me make this color darker somehow. Let's do that. That's too close to the other color. Let's try this. Okay. Is that better?
Yeah. Thank you.
Okay. So, believe it or not, that symbol is telling you to add a certain number of numbers and also what the numbers are. Believe it or not. So, here's what I hate you. So here's what this all means. On the bottom, this is telling you where to start. This is telling us to start with the first term. This is telling us to start with the first term. The number on top tells us where to end. So in this case, this is telling us to start with the first term, end with the fourth term. This is our explicit formula. So those of you that have not watched the video from last time, this is not going to sound familiar. But that 2n is our explicit formula to actually find the actual terms. The bottom on the number tells us what term to start with. The number on the top tells us what term to end with. And then the expression after sigma will tell us how to find the actual terms. So let's go ahead. The first example is actually pretty similar to what I just showed you. So this first example, again, is very similar to what we just looked at. The bottom, this is telling us to start with term number 1. On the top, this is telling us to end with term number 6. Now let me make something clear. This does not mean add 1, 2, 3, 4, 5, 6 together. No, 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 no. It means add term 1, term 2, all the way up to term 6 together. We don't know what those terms are yet. We have to find them. That's what the 2K gives us, okay? So to find term 1, we plug in 1. So we are going to say 2 times 1, which is 2, plus, because a series is a sum, okay, we need to find the second term. So 2 times 2, which is 4. We need to find the third term, so 2 times 3, which is 6. We are going to continue that up through what? 6.
Wait, so are we just assuming that the numbers are in order?
What do you mean?
Like, we're just assuming that it's just like 1, 2, 3, 4, 5, 6.
Yes, because to find, using an explicit formula, if you plug in 1, that finds the first term. If you plug in 2, that finds the second term.
Oh, okay.
Yeah, this explicit formula will be different. It's not going to always be 2 times whatever. Okay? And then finally, 2 times 6 gives me 12. Okay, a couple of things that I want to point out to you. The directions say to write the terms of each series. That's what this is. That's the 2 plus the 4 plus the 6 all the way up to the 12. Okay? Write the terms of the series. That's what we have here. Then evaluate. What do you think that means? Exactly. When it says evaluate, just add them together. So 2 and 4 is 6, and 6 is 12, and 8 is 20, and 10 is 30, and that's 42. Okay. So these are the terms. 42 is the actual sum. Go ahead and look at the next example then. So here, what we have is, first of all, we'll start at term 1 again. We will finish or end at term 4. The explicit formula is just K. Which actually makes our lives kind of easy. Because if you think about plugging 1 into here to find the first term, you just get what out? 1. If you think about plugging 2 in for K, we just get out 2. So the actual terms are just 1, 2, 3, 4. But wait a minute. We have that 1/2 coefficient. So think about taking 1/2 of each of those So the actual terms would be 1/2 plus 1 plus 3/2 plus 2. So these are the terms.
So we couldn't like just add those together and then divide it by 2?
Well, because it asks for the terms.
Okay.
Yeah. If it does not ask for the terms, sure, you could go ahead and add them, divide by 2, that's your sum.
Okay.
But because it's actually asking for the terms, we need to make sure we know each individual one. So if we add those, what do we end up with? So the sum is actually 5. Okay. Let's move on. We have a couple of properties for our summations that will help us a little bit in what we're going to do last. Let's look at the first one. So this C is just indicating a constant. We can take that constant and we can move it to in front of the sigma. So we can rewrite this as the constant times the summation. And once we get into an example, you'll see how this is actually going to work. I know it's kind of vague right now.
Do we need to write the N and the K goes around?
Yeah, I mean, I was just kind of going quick here, but we probably should. And then the second one, so notice that you have two terms being added inside of that quantity. You can split that summation up. So we can find the sum of the first part and then plus the sum of the second part. Take constants to the front, split up any terms that are being added. Okay, take your constants to the front, split up any terms that are added. Yes, ma'am.
Can you go back over to the first one really fast?
Yep. We have formulas that, depending on what type of series you have, will find very quickly the sum of the series. Because let's say that number on top was 1,000. I sure don't want to sit here and plug in 1, 2, 3, all the way to 1,000 to find 1,000 terms. Do you want to do that? Not really. Okay. So what these formulas will do for us is calculate the sum. Basically, it's a shortcut, okay? So, let's say we have a constant series. So, if you look at the example, it actually is kind of helpful if you look at the examples to see exactly what we're talking about. So, constant series, for instance, just 10. There's no variable there, which means what? Every term is what? Exactly. Because if you plug 1 in, it's still 10. If you plug 2 in, it's still 10. Every single term is just 10. Quick way to find the sum of this. Any ideas? Yes, multiply. Because if the first one's 10, the second one's 10, the third one's 10, 10 plus 10 plus 10 is 30. Multiply those, it's the same thing. So, that being said, with a constant series, we are going to multiply n and whatever the constant is. So n and c. So in our specific example, multiply the 3 by the 10, the sum of that series is 30. Say we have a linear series, so a variable to a power of 1. what we are going to do to find the sum of a linear series, we are going to take our value of n. We are going to multiply it by n plus 1, and then we are going to divide all of that by 2. It's all right. Just
Do you have to remember these for the test?
no. I will give it to you.
Wait, you need to pause for a second.
That being said, look at this example. Again, your value of n is 3. So to find the sum of this series, we are going to take n, which is 3, times n plus 1, so 3 plus 1 is 4, all divided by 2. So 3 times 4 is 12 divided by 2. The sum of this is 6.
And that works for like any.
Yep.
And it's the same thing. It's always n.
Mm-hmm. As long as your series is linear, variable with the power of 1. Variable with a power of 1.
Not like k squared.
Right, we're going to look at squared next. Okay.
Okay.
All right, last one, because Brianna brought it up, quadratic series. So in this case, k squared. Okay. Please don't freak out. N times n plus 1 times 2n plus 1 over 6.
Just figure this out. Yeah, really.
Did I not tell you you won't be able to figure it out?
Like, how much of their life did they spend on this?
Honestly,
And on this example, if our value of n is 3, notice you have a quadratic series, variable to the power of 2. N is 3 times, what's n plus 1? 4. All right, what's 2n plus 1? So plus 2. 2 plus you again. 2. 2.
Why did you say it? What?
So 2 times 3 is
6.
plus 1. That's where we get the 2n plus 1
Is it not?
all over 6. And then just simplify. So that's 84 over 6, which is 14 exactly.
that's not too bad.
Is it likely that we'll have full numbers? Like if we were having these on a test?
I don't like
Yeah. Except you're going to be mad at me. I totally forgot something.
Oh, no.
We totally did not take into account this 10.
That's what I was literally just going to ask you.
Yeah.
It's like a log where it had to be like 10.
No, what we did on this example was we found the sum with just the k. So we just need to take into account that 10. So just multiply 6 by 10. The sum should be 60. Yeah, it's not a big deal. It's not a big deal, but I just realized it because we did it on the last. Yeah, we need to do the same thing. So not 14 because we need to take into account that 10. So it should be 140. My bad. I'm sorry about that.
So you just multiply it to whatever
times
the last
10.
one's. Wait, you don't have to. So you get like your squared formula with.
So let's look at the first example. So we have the explicit formula is 2n minus 12 going from term 1 to term 7. Now, again, you could certainly plug in 1, plug in 2, plug in 3, plug in 4, all the way up to 7, add them up. But we have shortcuts, so let's use them. So what we're going to do, first of all, is any plus or minus we're going to split up into separate summations. So I'm going to start off by rewriting this as the sum of 2n from 1 to 7 minus the sum of 12 from 1 to 7. Okay? Splitting those up into separate summations. Just splitting them up into separate summations.
Why couldn't you just...
So let's do this. let's think about the first summation. First of all, is this constant, linear, or quadratic? Linear. Linear. All right, so we are going to use the linear formula. So keep in mind that our value of n is 7. So the linear formula is n times n plus 1, which is 8, all divided by 2. Go ahead and bring down that 2 so we don't forget to multiply like we did on the last 2 examples.
Doesn't technically that 2 and
Yeah.
that 2 cancel out?
Yeah. Yeah, but you won't always have a 2.
Yeah.
But in this example, yes, they would just cancel out. All right, let's look at, bring down your minus sign. Let's look at the second summation. Is this constant, linear, or quadratic? Constant. This is the easy one where we can just multiply 7 times 12. Now we need to simplify each one. So like Carly said in the first part, those 2's do cancel, so this is 56. Minus 7 times 12 is 84. So the sum of these is negative 28. Look at the next one. There we go. All right. Start off. Separate these into, this time we'll have 3 summations. Okay. So we have the sum of 4n squared from 1 to 5 minus the sum of 2n from 1 to 5 plus the sum of 7 from 1 to 5. All right, so let's look at the first summation. Is it constant, linear, or quadratic?
Quadratic.
Quadratic. So use that quadratic formula. We have n, which is 5. We have times n plus 1, which is 6, times 2n plus 1, 11, divided by 6. Now don't forget that 4 out in front.
Why does that have to be divided by 6?
Because that's just the formula for the quadratic. But don't forget that coefficient of 4 out in front. I did it, so now you guys are going to do it all the time. I hate when I do stuff like that. Okay, let's look at the second summation. So we have minus. Let's go ahead and bring down that coefficient too before we totally forget. Is this constant, linear, or quadratic? Linear, so we'll have n times n plus 1, which is 6, divided by 2. And then finally plus, is the last one constant? Linear, okay. So this is just when we multiply 5 times 7. Now we just need to simplify. Does anybody have this first part simplified by chance? Thank you. Minus, that would be 30 plus 35. All of this comes out to be what? 2 what? 225. Thank you.
Oh, I mind.